All right, so what we're going to do today on this lesson is algebraic equations instead of expressions. Okay, so this time, what's the big difference between the problems we had before and what we're going to do today? That word equation, what is it? Yeah, we're going to find out what x is, but what does this word equation kind of have in it? It kind of has it. Equal, that's right. See the EQUA? It's got an equal. So now we are going to have an equals. So we're going to have a left side and we're going to have a right side of the equation with an equals right in the middle. Make sense? All right, and we're going to absolutely solve for either x or y. So we're going to start off real simple. I know you've already had this stuff before. This is review though. Okay, we'll start off real easy and then work our way up. So here's an example. It's x minus, today is the 30th. X minus 7 equals 16. All right, we're going to get x by itself. So you look to see what's with the x. How do we get rid of stuff? Well, we do the opposite in algebra to get rid of stuff. So what is this 7 doing to that x right here? Kenny, what's that 7 doing to that x? And what's the opposite of subtraction? Addition. So we add a 7. Now, remember in algebra, whatever you do to one side, talk to me, you got to do to the other side. So whatever you do to this side, you have to do to the other side as well. All right, to keep everything balanced, to keep it equals. So negative 7 plus 7, that just cancels out, doesn't it? All right, x equals, and what's that? 23. And there you go. And you circle it. Now notice, I went through a certain way of doing it. I wrote the problem down. Do you see that? I showed all my steps, even though I could have done this in my head. I mean, I could have sat there, looked at this problem, and just said, oh, that's 23. But that's not what I want to do on my work. Okay, on your homework, I want you to write the equation down, show your work, show your answer. All right? You can either put it in a box, underline it, circle it. I like circling it, but whatever. You got it? Okay. Let's do another one. This is just as easy. Now, you don't always use x, do you? A lot of times it seems like it's the favorite of math books, but it's kind of my favorite too, because I'm used to doing it. But you can use other letters as well. This time we used M. Now, what is this, Dion? What's this 12 doing to this M right here? Okay, I'm asking Dion. All right. So how do you get rid of that plus 12? It's being added. How do you get rid of it? That's right. You put a minus. And look, I put it underneath. All right. I like to put it underneath and not to the side of it. Some people put it to the side. Yeah, but I think it's a better way to put it underneath. I really do. Okay, so try to get into that habit of putting it underneath instead of to the side. It wouldn't be wrong if you did it that way. I think it's just better to do it this way. So let's see what happens. These 12s cancel out, or they add up to 0, technically is what's going on. So I've got M equals, now look at this, it's negative 5 minus 12. Remember the thing we just did before? Add the opposite, so it's negative 5 plus negative 12, which is negative 17. Good. All right, showed all my work, showed my answer, wrote down the problem. It's exactly the way you should be doing it on your own homework problems. Good. All right? Well, that's too easy, isn't it? Let's get to something a little more difficult. Well, actually, you like it the way it is?
Yeah.
Actually, this is even easier, I think. Look at this. 4D equals 36. Now, what is this D? Daenerys, what is this 4 doing to this D? You don't know? Is it being added? Subtracted? You see, you do know. So it's being multiplied, he said, okay? Now, Daenerys, I'll give you a chance to redeem yourself. How do you get rid of something if it's being multiplied? What's the opposite of multiplication? Good. Division. You're right. So you divide by 4. Notice how I showed division. I didn't... See, back when you were a kid, you did division like this. Remember that little symbol? But when you got into algebra, you started doing division like a fraction, all right? So you put it over 4, and that's how we're going to do that. So you divide both sides by 4. Look, the 4's cancel out. Now, when I say they cancel out, really what are they doing? Up here, these added up to 0. Now, we said they canceled out, but they're actually doing two different things. These are adding up to 0. What's happening here? Are these adding up to 0?
No.
What are they doing? It's making a 1, and 1 times D. That's right. Anything times 1 is itself. Good. All right, so we say cancel out. I'm not going to yell at you if you say cancel, but I want you to know what's going on here. They don't just go away into nothing. What happens? They divide out to be a 1. 1 times D is D. Got it? All right, so D equals what? 9. All right, just like that. Easy, easy. All right, now those are the easiest ones. Now we're going to get into some that cause a little bit more trouble for people. Actually, maybe not this one so much, but the next ones. All right, it's negative t over 8 equals negative 7. Now again, I want to get t by itself. So I need to get rid of the negative, and I have to get rid of the 8. Now, what's this 8? Scrappy, what's this 8 doing to that t? How do you get rid of something that's being divided? You multiply. Okay, so watch. I multiply by 8, and I come over here and I multiply by 8. But let's also, instead of saying just multiply by a regular 8, let's get rid of that negative by multiplying by a negative 8. You see what I'm doing? I multiply by a negative because it's negative times negative is positive, so I multiply that side by a negative as well. So watch. That cancels with that. This negative times negative is a positive. I'm left with t. What's this going to be? It's negative 7 times negative 8. What's negative times negative? Positive what? 56. And there you go. That's all there is to it. Does it make sense? Alright, so if something's being divided, you multiply it to get rid of it. Alright, now this is the one where I was talking about. So watch. 3/5 x equals negative 8. Alright, Joel, what's that 3/5 doing to the x? It's multiplying. Okay, so normally, the questions I've been asking so far, we always do the opposite. So what's the opposite of multiplication? Division. Now, this is where it's a little different. You watching? You could, if you wanted to, you could divide by a 3/5. But then you're going to have to take this and divide by a 3/5. That's a little ugly, isn't it? Remember, let's go back to this thing. Remember when you were a kid and you did this division? Right. Like if I was going to divide by, I'm just making up a number. Let's say 2/3. Okay, what if you had a number divided by 2/3? What did you do when you were a little kid when you first did this stuff? You change it to, Kenny, you said it earlier. Say it again. That's right. You multiply by what? The reciprocal. So dividing by 2/3 is the same as multiplying by 3/2. Remember doing that when you were a kid? Same thing here. So instead of dividing by 3/5, what are you going to do? Multiply by 5/3. And do you understand why it works? Because look, the 5's cancel and the 3's cancel, don't they? That's the whole idea. We want to try to get rid of stuff. So if I multiply by 5/3 on that side, I'm going to multiply by 5/3 on this side. So look, the 5's cancel, the 3's cancel. I have just an x equals. Now I'm going to put this over 1. Does anything cancel here? Does 3 go into either one of those? No. So we just write it negative 40 over 3. Just keep it like that. There's really no good reason to change that to a mixed number. Maybe if it was a word problem and they're talking about the length of something, then you could change it. But if it's just a straight up math problem, I would just keep it just like that. I wouldn't even change that to a mixed number. What? Don't want to though. This is the easiest way to do it. Okay, I would not change that to a decimal. All right, it's the easiest way to do this is the way I did it right here. All right, and that's the way I want you to do it when you have fractions. Okay, if they give you fractions, work with them as fractions. Don't work with them as a decimal. Because what if it didn't come out even? What if it came out to a repeating decimal or something? You don't want to use decimals with that. So use fractions. Everybody got that? All right. All right. Let's pause that and we'll start a new type of problem. We got like 3 more examples to do, okay? All right, let's look at this one. They use a Q on this one. I'm not going to. I'm going to use the X. My Q's look terrible. So I'll just use the X. It doesn't really make any difference. All right, there you go. Now this is a little bit different because before we basically only did one step, right? We either subtracted something from both sides or we added or we multiplied or we divided. That's really all we did. We did one step. Now this time it's going to take more than one step to get that X by itself, because there's more going on that side than just one thing. So first thing we do is we get rid of what's being added or subtracted first. Okay? Get rid of what's being added or subtracted. So what is being added or subtracted to this X term? The 15. So I'm going to get rid of that. It's being subtracted, so I add it. Right. So I add a 15 to both sides. Okay? 15s add up to 0. They cancel out. Bring everything else down. So that's an 8x equals 49 plus 15. What's that? 64. Is that right? Yep, that's 14. Carry the 1. That's a 6. Okay. And now, yeah, now it's just like we did earlier. Now it's just one step from here on out, isn't it? It's just divide by 8 on both sides. The 8's go. X is what? 8 eighths are 64, aren't they? Okay, that's what I thought. All right. 8 nines are 72, right? All right, so there you go. We good with that? All right, it's a two-step problem. You did tons of this in Algebra 1, didn't you? Yeah? Yes? Yes, you did. I'm telling you right now you did. Because that's what most of Algebra 1 was about, was that kind of stuff. Here's another one. Same kind of deal with one little extra added twist. What's the little twist on this one?
You gotta do to both sides.
Yeah, you got variables on both sides, don't you? Do you see that? You got a y here and you have a y here. We don't want y's on both sides. We want y's on the same side. And does it really matter what side you put it on? Doesn't make any difference. Now, I kind of have a preference. I like to take the smaller one and put it on the side with the bigger one, so that way it keeps it positive. All right? Some people always like to put stuff on the left side. That's fine. If that's the way you like to do it, that's fine with me. I kind of like to make sure that it's always going to be positive. So how am I going to get rid of the 6y? Not the 6 by itself, but this 6y, because it's acting as one term. What's that 6y doing? It's adding. It's adding. See, this is one term by itself. I'm just looking at this one thing right here. Okay, it's adding to this -5, isn't it? So how do I get rid of something that's being added? I subtract it. All right. All right, so look, the 6y's go, don't they? Because 6y minus 6y is 0. Now, I'll do this in a second, but watch. Some teachers will... Anyway, this is the way I'm going to do it. I move the y over in the same step. Let's take this 8 and move it to the other side, because now I have the y on the left side. Let's take this number and put it over here on the right side. So how do I get rid of this +8?
Minus.
That's it, -8. All right? They go right there. See, I kind of did two things in one step right here. Now we can go ahead and do our subtractions. 12y minus 6y, 6y. That thing canceled out. That thing canceled out. This is, excuse me, -5 minus 8, which is -5 plus -8. So it's -13. Okay? Divide by 6. The rest is a piece of cake. Now, do you have to change that to a decimal? Do you have to change it to a mixed number? No. There you go. Just keep it just like that. That's how I would keep the answer. I wouldn't even change that to a mixed number. I would keep it exactly like that. Let's do one more. Again, another little bit of a twist. But this is all review, isn't it? I hope it is. This is basic Algebra 1 kind of material. All right, look at this. Well, we just have one variable on this side, but look, we got a parentheses. We didn't have parentheses on those other problems, but what does that mean? You take that 3, good, glad you used that word, distribute, that's the word, distributive property. Do you remember that from algebra? So you take that 3, I like to do this, I like to put these little arrows, right? So it's 3 what? 3x minus 15, right, because it's 3 times 5 equals 13. Now it's what we've done before. This is minus 15, so how do you get rid of it? Plus 15, right, do it to both sides. And then that cancels. 3x equals, what's that? 28. Divide both sides by 3, and x is 28 over 3. Now that doesn't simplify, does it? Now if 3 did go into 28, then you would reduce it. It doesn't, so you just keep it just like that. No reason to change it to a mixed number. No reason to change it to a decimal. Keep it exactly the way it is. We good? All right. If you weren't sure about this, go to YouTube. It's all on there. All right, use it as a great reference. All right, so now we're going to do section 05, and I'm actually only going to give you the evens tonight. All right, and I'll give you the odds tomorrow. So we're only doing the evens tonight. Yep. All right, everybody want to say bye?
Bye.